For factor formula for any angles of A and B, we have two different types of formula. For the first one is for sum to product and the second one is for product to sum. We have four different formulas to choose from. For example, if you have sine A plus sine B, so the formula is 2 sine A plus B over 2 cos A minus B over 2. If let's say the question is asking for cos A minus cos B, it's going to be negative 2 sine A plus B over 2 sine A minus B over 2. For product to sum, for example, if you have sine A cos B, the formula is 1 over 2 sine A plus B plus sine A minus B. And for example, if we have cos A cos B, it's going to be 1 over 2 cos A plus B plus cos A minus B. Let's discuss example 14. Express the following as a product of two trigonometric functions. So we have sum to product here. So we have A is 6 theta and B is 4 theta for part A. So the formula is sine 6 theta plus sine 4 theta. So the formula is 2 sine A plus B, so 6 theta plus 4 theta over 2 cos A minus B over 2. Simplify to get 2 sine 6 plus 4 is 10 divided by 2 is 5 theta. Cos 6 minus 4 is 2 divided by 2 cos theta.
For example 14b, our A is 8 theta, our B is 4 theta. So we're going to use the third formula where cos A plus cos B equal to 2 cos A plus B divided by 2. So 8 theta plus 4 theta divided by 2 times cos A minus B over 2. So 8 theta minus 4 theta divided by 2. Simplify the expression. So 2 cos 8 plus 4, 12 divided by 2, 6 theta cos 8 theta minus 4 theta. We're going to have 4 theta divided by 2, 2 theta. So the answer is 2 cos 6 theta cos 2 theta.
For example 15, we need to change from the product to sum. So for part A, our A is 6A and our B is 2A. So the formula for this one is sine 6A sine 2A is equals to negative 1 over 2 cos A plus B. So that will be 6A plus 2A minus cos A minus B, which is 6A minus 2A. Simplify to get cos 8A minus cos 4A.
For example 15b, our A is 5A and our B is 3A. Since we have product of cos and cos, so we're going to use this formula, the third formula. So according to the formula, so cos times cos equal to 1 over 2 cos A plus B, so cos 5A plus 3A plus cos A minus B, cos 5A minus 3A. Simplify, so 4 times half became 2 cos 8A plus cos 2A. This is our answer. For example 16,
we're going to find the exact value of sine 105 sine 15 without using calculator. So first take note, A equal to 105, B equal to 15. So since we have a product of sine and sine, according to the previous note, we're going to use the last formula, where sine A sine B equal to negative half cos A plus B minus cos A minus B. Okay, substitute A and B into the formula. So sine 105 sine 15 equal to negative half times with cos 105 plus 15 minus cos 105 minus 15. Simplify, we get negative half cos 120 minus cos 90. Since we need to find the exact value without using calculator, first we must make sure that our angle is an acute angle. So 90 is an acute angle, but 120 is not an acute angle. So how to change into an acute angle? So first, draw 4 quadrants. So 120 is in the second quadrant. Alright, so in the second quadrant, cos is negative. So negative cos. And for the angle, we're just going to take the reference angle. So in the second quadrant, this is the reference angle. So how to get the reference angle? 180 minus 120 degree. Okay, minus cos 90. Simplify, we get negative 1 over 2 times with negative cos 60 minus cos 90. To get the value of cos 60 and cos 90, previously, we have learned to find the value of certain trigonometric ratio for some particular angles. So since we need to find cos 60, so cos 60, the value is 1 over 2 times with negative 1 over 2 minus with cos 90. So according to the table, cos 90 is 0. So minus 0. Simplify and we get the answer as 1 over 4.
Okay, now we're going to discuss on how to find solutions for trigonometric equations. Okay? So we have a step here called bracket. So what is bracket? Bracket is basically BA stands for basic angle. The second step is to find the quadrant. The third step is to find the interval. The last one is to rotate. Okay, don't worry, we're going to discuss on bracket steps in our examples after this. We also have a special angle that we can get by using graphs. For example, in order to solve sin theta equals to k and cos theta equals to k, if we have the k values of negative 1, 0, and 1, you can take a look at the graph here. So for example, when you have k equals to 1, for sin theta over here, the answer will be pi over 2. And for example, we take sine 3 pi over 2 over here, then the answer will be negative 1. For cos, if let's say we have k equals to 1, therefore the answer is, for the theta will be 0. Okay? And then if let's say we take 3 pi over 2 as the theta, for cos 3 pi over 2 over here, then the value of k is 0. Alright? Example 17. Find the values of theta where theta from 0 to 360 for sine theta equals to a half. Alright, so let's start. The first step is to find basic angles. Alright, so alpha is basically arc sine 1 over 2. And the answer is 30. The second step is Q to find which quadrant, and the question is sign positive. So it's in quadrant 1 and 2. So this is basically our alpha. The third step is to find the interval. So the interval is from 0 to 360. And the last part is to rotate. Okay, so let's rotate. So the first rotation is the basic angle, which is 30. Okay, the second one is basically 180 minus the basic angle, which is 150. So that's the answer. For part B, we have cos theta, cos 3 theta minus 75 equals to 0.5. So we're going to start our bucket. So for the first one, we're going to find the arc cos for 0.5. And the answer is 60 degrees. For the quadrant, cos is positive from the first and the fourth quadrant. For the interval, we start off with 0 to 360, but since the question actually asks for 3 theta minus 75, so we have to multiply by 3 and deduct 75. So it's going to be negative 75 until 1005. And for the rotation, it's going to be 3 theta minus 75 degrees equals to, so the first one is 60. Next, we rotate to the fourth quadrant and we get 300. But since the maximum is 1005, we need to rotate again. So we're going to add up 360 from 60 and 360 from 300. So it's going to be 420 and 660. We haven't reached our maximum yet, so we're going to add another 360 for both of the values. So 420 plus 360 is 780. And 660 plus 360 is basically 1020. But this one already exceeds our maximum value here. So we can simply ignore it. But then, you can notice that we actually move from 0 to 75, negative 75. Okay, so we still have to rotate this way. And we figure out that there is another one value, which is negative 60. When we try to rotate the other way, it exceeds negative 75, so we can ignore the value. So when we add up 75 for each one of them, plus 75 and divide by 3, You're going to get the final answer of 5, 45, 125, 165, 245, and 285 degrees.
Example 18, given cosec squared x minus cot x equals to 3, we have to show that the equation can be cot squared x minus cot x minus 2 equal to 0. So for proving question, first of all, we have to refer to the basic identity, which is cot squared theta plus sin squared theta equals to 1. From this basic identity, we can derive another two identities. So since we want our equation to be in terms of cot, so we're going to replace cosec squared theta, cosec squared x with cot squared theta plus 1. So first copy down the equation, cosec squared x minus cot x equal to 3. Then substitute cosec squared x with cot squared x plus 1 minus cot x equal to 3. Rearrange. So cot squared x minus cot x, 1 minus 3 become negative 2. Shown. Hence, solve the equation cosec squared x minus cot x equal to 3. Use the previous shown equation. So cosec squared minus cot x equal to cot squared x minus cot x minus 2 equal to 0. So next we have to factorize, or to make our equation simpler, let cot x as other variable. So now we're going to have y squared minus y minus 2 equal to 0, a quadratic equation. So factorize the quadratic equation, y minus 2 times y plus 1. We get y equal to 2, y equal to negative 1. Substitute back y equals to cot x, and we're going to have cot x equals to 2 and cot x equal to negative 1. So now we have two equations and we have to solve both equations. In order for us to solve trigo equation, our trigo equation must be in terms of tangent power 1, cos power 1, or sine power 1. Since we have cot x equals to 2, so we have to change it to be 1 over tangent x equal to 2. Rearrange tangent x equal to 1 over 2. Same goes to the other solution. Cot 1 over x, cot x equal to 1 over tangent x, which equal to negative 1. Tangent x equal to negative 1. Then we're going to use the Bakir method. So bar, BA stands for basic angle or the reference angle. So alpha equal to shift tangent modulus 1 over 2. So shift tangent modulus 1 over 2, 0.4636. Next, the second step is Q stands for quadrant. We have positive tangent. So tangent will be positive if it's in the first and the third quadrant. The next step is I, the interval. It is mentioned in the question that x is in between 0 to pi. So this is 0 to pi. So the only angle that we can found from 0 to pi is the angle in the first quadrant. So the rotation x equal to angle in the first quadrant, which is 0.4636. For the second solution, for the first step Bakir, bar stands for basic angle, alpha equal to shift tangent modulus negative 1. So when we calculate shift tangent negative 1, so positive 1 equal to pi over 4. Then check the quadrant. We have tangent negative. So tangent will be negative if it's in the second and the fourth quadrant. And for the interval, since it is mentioned that x in between 0 to pi, so from 0 to pi, the only angle that we can find is in the second quadrant. So how to get the angle in the second quadrant? X equal to 180 minus, or since we have angle in radian, so pi minus with the reference angle, which is pi over 4. So the answer is 3 pi over 4. Finally, our x is 0.4636 radian and the other one is 3 pi over 4.
Example 19. We have to solve the equation 2 cos square x minus 1 equals to sine x, and we have to give answer in pi. Okay, so let's start. So basically we know that cos square x plus sine square x equals to 1. So we have to replace cos square x. Substitute with 1 minus sine square x followed by negative 1 equals to sine x. Expand to get 2 minus 2 sine square x minus 1 and bring sine x to the left hand side to equal 0. Negative 2 sine square x minus sine x plus 1 equals to 0. Before we can factorize, we have to make sure that the coefficient for sine square is positive. So, divide everyone by negative 1 to get 2 sine square x plus sine x minus 1 equals to 0. Factorize to get 2 sine x minus 1 and sine x plus 1. So from here, we'll get two different set of answers, which is 2 sine x minus 1. So to simplify, we get 2 sine x equals to 1 and sine x equals to 1 over 2. The other one is sine x plus 1 equals to 0. Therefore, sine x equals to negative 1. Next, we have to follow the 4 rules, which is Bakir. The first one is bar, basic angle. So alpha is arc sine 1 over 2. And the answer is pi over 6. Next step is Q for quadrant. So sine positive is in the first and second quadrant. So this is pi over 6 and pi over 6. The third step is for the interval. So x, from the question, you can see clearly the interval is from 0 to pi, inclusive. And last one, rotate. So we're going to take the x. So x equals to, the first rotation is pi over 6. Like this. And the second one is basically pi minus pi over 6. And the answer is 5 over 6 pi. Okay, let's take a look at the other set of answer, which is sine x equals to negative 1. Repeat the same process again. So, you have to find the basic angle. So, alpha So arc sine 1. We're going to ignore the negative because negative will be considered during quadrant. So arc sine 1 is pi over 2. So for the second step, which is Q, which quadrant is actually sign will be negative? It's going to be the third and fourth quadrant. But let's take a look at my drawing. Pi over 2 is basically right here. Right? Okay. So we're going to delete the previous quadrant and draw like this. Okay? Because this is pi over 2 and pi over 2. So for interval, it's going to be the same, which is x is between 0 and 2 pi. But when we try to do the rotation, so the first rotation is this. Also for the second rotation. Okay? So the answer will be 3 over 2 pi only. So to conclude, the final answer is x equals to pi over 6 radians, 5 pi over 6 radians, and 3 over 2 pi.